Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and we are continuing our video series today by looking at our third index law, raising indices to a power, so the power of a power. This is our fourth video in the series. If you haven't watched the first three, do get in there and do that quickly. Okay, in this video we are going to look at how the rule gets made. We're going to do some worked examples, talk about what's coming up and how to engage the channel. Let's not waste time, let's get right into it. So I'm going to start with showing you how the rule works and what the rule is with a quick worked example. So in this particular case, we are looking at powers that are being raised to another power. So you've got powers next to powers. Usually we express this inside brackets. Okay, so when you've got a term inside the brackets, a power inside the brackets, and a power outside the brackets, this rule applies. Now, when you think about 3 to the power of 3, what that is, that means 3, the number 3, raised to the power of 3. 3 is the base. 3 is also the power in this case as well. It means 3 times 3 times 3. Now, it's being raised to a power of 2. We could also say it's being squared. What that means is 3 to the power of 3 times 3 to the power of 3. So we're multiplying it by itself. That's what squaring means. Now, if I was to follow my index law rules, I'm going to add the powers. So I'm going to do 3 plus 3, which makes 6. We can simply add those powers. And the answer would be 3 to the power of 6, as we just mentioned. So that means we can make a shortcut rather than having to, every time we see something inside brackets, write it out in full what it means. When we see something that's a power raised to a power with brackets, we've got a shortcut. We can simply multiply these together. 3 times 2 makes 6. That's a nice quick shortcut rather than doing this one here multiplied by itself, because if we had a power of 10, for example, you'd have to do that. 3 to the power of 3 times 3 to the power of 3 times 3 to the power of 3, 10 times. Pretty tedious. So basically what we have here, the whole idea of multiplication is repeated addition, and that's why this rule works. So here's our rule. Anytime you've got a bracket, set of brackets with something inside the brackets raised to a power outside the brackets, we can simplify that by getting rid of the brackets altogether, and we simply times the powers, and that's what mn means, m multiplied by n. Normally when we've got two algebraic terms together and we multiply, we just smush them together. So that's what that means. Obviously if these were numbers, if that was a 3 and a 2, we wouldn't write 32. That wouldn't be correct. It'd be 3 multiplied by 2. Let's do some examples and this will all become much clearer. So once again, we're using some real numbers. 4 to the power of 8 to the power of 4. So what that means is 4 to the power of 8 times 4 to the power of 8 times 4 to the power of 8 times 4 to the power of 8. 4 times. So let's write our rule first, rather than having to write that out all those times. What I'm going to do is simply apply my rule. 8 times 4 makes 4 to the power of 32. Okay, now once again, I could have used my addition rule. If I'd written that out and expanded it, it would have been 8 plus 8 plus 8 plus 8. And if you're not great with your times tables, that might be a good approach to take. However, this is much quicker if you know your times tables. If you don't know your times tables, maybe get a calculator. Okay, you didn't hear me say that. Okay, y to the power of 7 to the power of 3. Once again, we're going to write down our rule so that it helps us to set it up in the right way. So if we write our question underneath, if we follow our rule, it means 7 times 3 becomes our new power. Because what this means is y to the power of 7 times y to the power of 7 times y to the power of 7. So it's being multiplied by itself 3 times. So 7 times 3 makes y to the power of 21. Let's make it a little bit more difficult this time. Okay, you can see I've got a double set of terms inside brackets. Everything in the brackets is in the brackets, so everything in the brackets gets the power. Okay, so the j gets the power, the k gets the power. It all is happening here. So once again, write your rule, and you can see we're now going to change the j to the power of 4 becomes j to the power of 4 times 10, and k to the power of 5 becomes k to the power of 5 times 10. Okay, so one thing I do find is students do find this a little bit confusing after they've just got their heads around the whole idea that when they've got the same base and there's a multiplication in between, they've got to add the powers. And their natural instinct is to times them, and then suddenly they're now allowed to times them. And so my reminder to them is brackets always means multiplied. So whenever you see brackets and something stuck on brackets, it always means multiplication. So that's the only time you're permitted to times the powers, is with the brackets. Okay, we know 4 times 10 is 40 and 5 times 10 is 50. So we've got j to the power of 40, k to the power of 50. We're going to get a little bit harder again this time. This time I've put some whole numbers inside the brackets. Still 2 terms here. We'll treat them exactly the same, but this time we've got a whole number. And you'll notice it doesn't have a power. In fact, it actually has an invisible power that we don't normally write down, a power of 1. So we can still apply that principle, and it'll be 1 times 3. Or we just simply do 2 to the power of 3, which is what we're going to do. So we're going to expand that out. So notice here, I'm going to change this now. Each term I'm going to deal with individually. 2 to the power of 3 is written here. A to the power of 3, that'll be 3 times 3. B to the power of 11 times 3. Now, I'm going to simplify on the next line of working by using my times tables and working out that 3 times 3 is 9, 11 times 3 is 33. I'm not going to leave this as 2 to the power of 3 though, because to simplify this question properly, and usually the instruction is to simplify, I should be able to know what 2 to the power of 3 is. It's 2 times 2 makes 4, times 2 again makes 8. So anytime you see whole numbers like this and they can be simplified, do it. Okay, 8 to the power of 8 multiplied by 8 to the power of 9, b to the power of 33. Okay, our next example is a little bit more complicated again. This time you'll notice I've got a 4 squished out to the front of the brackets and then a whole lot of things inside brackets. Now this is something really important to remember. This 4 out the front does not have a power. Okay, only the stuff in the brackets gets the power of 2. If it's stuck to the brackets, it does not get the power. Okay, it's multiplied by everything else, but it's not going to get the power. So first of all, what we're going to do is we're going to deal with the powers over here first. So let's write our rule again. And so this becomes 4 times, because there's an invisible times between the brackets and the number here. So I've put 4 times. I'm taking those brackets away now. I've got 2 to the power of 2. Notice I've written that there. M to the power of 2 times 2. N to the power of 5 times 2. You can see why writing it as a step of working rather than trying to do it all in your head makes less mistakes. So now let's deal with this a bit more. We know that 2 times 2 makes 4. We know that 5 times 2 makes 10. And we know that 2 to the power of 2, or 2 squared, is 4. So we can simplify that again. 4 times 4 becomes 16. M to the power of 4, N to the power of 10. Well, hopefully you found this video helpful. You might be wondering what's coming up next in the series. Well, we've got some more laws to talk about and unpack. We're going further on though, well beyond year 9 work. We're going to look at surds, we're going to look at logs, we're going to look at some complex combinations with algebra as well. So we're taking this right up into years 10, 11 and 12. So if you are looking into the senior years, this is the place for you. Well, did you find the video helpful? And if you did, you can engage with us further in a number of ways. You could like and subscribe to the channel. You could hit that notification bell so you always know when we've got a new video coming. Tell us in the comments if you found it helpful, or even consider sharing the video with a friend, a teacher, or a family member. You can also follow us on Facebook and Instagram. And if you have any questions at all about anything you've seen in the video, mcclutchymaths@yahoo.com is the place to email us. Well, thank you so much for your time today. I'm Natalie McClutchy. Have a wonderful day.